Okay, I don't want to start any conspiracy theories, but here are some facts. In 1969, 16th of July, which is exactly 56 years ago, Apollo 11 went to the moon, and the computer that was powering that rocket was called Apollo Guidance Computer, which was running at 1024 megahertz with about 2 kilobytes of RAM. Let's put it into 2025 terms. This smartphone here has roughly around 355,000 times the computing power of Apollo 11. And this little $500 creator computer has roughly about 70 million times the computing power of the Apollo 11. And now this monstrosity over here has about 533 billion times the computing power of Apollo 11. And I need 2 power supplies to power it. Why haven't we been back to the moon since? That I don't know. But what I do know is this computer is insanely powerful, and a lot of creative professionals need that power in 2025. But what exactly can you do with a PC this powerful, and do you need to be a rocket scientist to build it? Obviously you don't, because if I can do it, you can do it. And in a minute we're going to be rolling back time, and then you can actually see how we did it. But you do need a bit of a house deposit to afford it. And if that's not a problem, it's time to build the rocket ship. Here's the thing, since the case is so big, like a rocket ship, it comes in multiple pieces, and it's not like small pieces that it comes in. They're massive, absolutely huge. And when you look around the case and undo some of the panels, you realize that there's a lot of cooling options, and that's exactly what you need in a PC that is super, super powerful. We've got cooling in the front, top, sides, both sides, back and front if you wanted to. It's super easy to install, and all the brackets and everything come off. There's a really cool hinge on the glass on the side as well, but that's just the case. Now, after the case has built, and bear in mind, you can actually get multiple of these pieces. You can see my extension piece on the bottom. You can get one on the top and then a few more on the bottom if you want. So you can really build this out like a Tower of Babel if you want to. What I'm needing to do now is, because I don't fully know what the final GPU layout is going to be like, I need to really try how the PCI lanes line up and how many GPUs can I actually fit. Because at this point of the video, I don't yet realize that there are secret compartments where the GPUs can live. Now, since I'm waiting for some of the PC parts still to arrive, what I do have is storage, and buttloads of it. I have got 100, in fact over 100 terabytes of SSD storage. Some of it, one of the fastest SSD storage you can find on planet Earth. But most of it is crucial BX500 4 terabyte SSD drives. And these are 2.5 inch, but I have got 26 3.5-inch SSD bays on this PC case system. So I can actually, if wanted to, fit a ton of hard drives in here. But since I want it to be a little bit quiet and want to actually lift it without a forklift, I'm gonna use these. And these are a lot faster than hard drives as well. So getting those installed takes some time. So as you can see, listening to music might be a good idea. And we're gonna get these done. And after that, we're really taking the first look into the cooling of this, because if this thing is not cooled, it's a big fire hazard. We're gonna have to cool it somehow. And because it does have multiple ways of cooling it, we're gonna be installing a few of these fans in the front. Thermaltake, which also does the case, has really cool fans. I think these are new. They just clip kind of magnetically together, so you can just install them in whatever variation, so you don't necessarily need lots of different cables that come from each fan, but they just kind of daisy chain together. We've seen that before with some clips or some other kind of slide locking mechanism, but never really with magnets that just kind of clip together, so that's new. I'm installing 4 of those in the front, and in the later part of the video you'll see there's going to be a lot more of those installed in some other places. Also, don't forget, we need to install the power button for this PC, because it's very, very special. It's really cool. It just works like an industrial on and off. So that gets installed as well. And there's multiple configurations wherever you want to put this. So I actually moved it further down. Now here's the thing, this is probably the most exciting part because now we're building the actual brains of this PC. This is where all the components that actually give it the power come together, and that's why it's called the motherboard. The mothership, this is where everything gets connected together. In a usual gaming PC setup, the install is a lot different than in this setup over here. You have to be very careful. You've been actually given special tools to install the CPU because the CPU needs to be on a special tension, and you need to have a clutch on the actual torque screwdriver that puts special pressure on each of them, because otherwise you might lose some memory channels, some cores, instability. It's a lot different. Oh, and did I mention that there's 1 terabyte of RAM in this PC? And this is how you get that installed. 1 terabyte. That's as much as my personal computer's operating system drive. We've got that on RAM. Bonkers. And obviously because the motherboard is so big, a lot bigger than just usual motherboards, we're gonna have to move some of these standoffs around inside the PC case to finally fit it inside this PC case. And there's no problem fitting it in there, as you can see. But what is a problem is the power. This guy doesn't just need 1 rocket thruster to give you kind of boost. It needs 2. What I'm talking about is power supplies. Usual PC has 1 power supply. This one has 2. In a minute, you're gonna see how I'm maxing out the 2 as well, and perhaps I needed a 3rd one, or even more powerful 2 ones, because that's a lot of power. But what makes this power supply installation a little bit tricky is the actual moving around the cables and figuring out where the cables are going to be, because there's 2 power supplies, so now they're sitting in different positions, and routing some of these cables might not be as simple, and figuring out where the GPU is going to be. Are we going to take the cable from the upper or the bottom power supply? That's something to figure out that you'll never know until you actually start to try it, and then you realize that cable's not long enough, or that can't go there, or that thing is blocked. So you're gonna have to be creative. What you might be thinking is, how on earth are you gonna cool this piece? Because that must be complicated, and we don't want to happen what happened to Challenger with our PC here. Believe it or not, the cooling of it is actually quite simple. You'll see performance in a minute, but what we do need is just a special cooler that covers the whole IHS of the CPU. And we need a cooler that just makes the equal contact. We don't want something that has a smaller contact, so you have a lot of empty space around it. You need something special that's made for this kind of rocket ship. And we've got one for thermal take, and this is a very interesting one actually. This is 360 millimeters. Bear in mind there is 420 millimeter radiator that I would highly recommend if you can, because I think it would fit better in there. But in this case, to actually use the same fans as push and pull, I'm using the 360 millimeter cooler, and it's plenty. As you can see in a minute, I can pull twice the power of what AMD is allowing or suggesting the CPU to pull. So once the cooler is installed, then we're just going to plug in everything else and do a test boot. It's basically a test flight. Let's see if the thing fires up and if everything's working. And then we can finally add all the other GPUs into this mix. Are there going to be any problems? Does it actually recognize everything that's plugged in? Will they all talk to each other? Here's the results. Can you see? Oh, we've got a post. We're booting. Yes. Since we're on a Pro workstation motherboard, don't expect much. We've got a BIOS like that. It's the old-fashioned, okay? Welcome back to 1995. I mean, come on. Asus people, have some respect for some even server guys, okay? We want a little bit of better graphics than what we have here. Basically, what we can see here is we've got 7995WX, 96 cores. We've got total memory, 1000 gigabytes. As you can see, that's a terabyte of RAM. It's running at 5200 megahertz. Maybe we can get it to run a little bit better. AI tweaker, memory frequency. We can see if we can run it faster. Target DDR5 is 5600. So that is actually within the spec. Actually, 5200 is within the spec. So I'm going to leave it at that. I don't want to get too much of kind of instability in here. But I want the build version is very, very old. We're going to have to update the BIOS. So let's update the BIOS, install the Windows, and I'll see you in Windows. A project like this, you usually expect a sponsored segment. Well, there is none of this, okay? This video is not sponsored whatsoever, and this took a lot of finances to actually make. So in this section, I want to quickly tell you about two of my favorite laptops that you can actually carry with you. One of them is this guy here, the Asus ProAd P16. One of the best Windows creator laptops that you can get on the go. Light, super powerful, efficient. I'm loving it. And there are rumors about the new upcoming version of this, which makes me super excited. If you don't know about this, check out the deals, and hopefully there's some back to school deals where you can pick this one up on a discount. I'll leave some links in the description below. The other laptop that I've worked so hard to get to actually show you is the Asus ROG G14. Now, I tested out the earlier version a couple of years ago and I absolutely loved it. It's one of the most viewed videos on the channel. But also, did you know that the G14 is the most rewarded laptop in the world, if I'm not mistaken? So if you want to check out that one as well, go check out the links in the video description below. Hopefully there's deals on both of them. I'll try to leave you the best pricing, so if you want to pick any of these up, check them out in the video description below. If you'd want me to go in depth on the channel about it, leave a comment below. Perhaps that helps Asus to get a sample for us. They don't know that I'm making this part, so back to the video. Now, once Windows is installed, the first thing I want to know is go to the task manager, show me the actual parts in there. I want to see all these cores laid out in there. I want to see the logical cores, 96 cores, 192 threads. Bonkers. So I want to see that. But then I want to see if all the SSDs are installed and everything in there. If you remember, in BIOS, I actually selected PBO on, which is basically just saying, hey, CPU, instead of pulling like your usual one, why don't you pull like twice the amount and give me all the performance you can get, or all the performance that you have in store in there, basically called overclocking. Let's see how much the PC is actually going to pull, and let's do a test if that 360mm AIO that's supposed to be rated for 350 watts, maybe a little bit more, can cool twice the amount. Not everything goes well. Watch what happens now. Package power. Take a look at this line over there. 289, 313, 360, 730, 742, 760. Come on. About 750 watts pulled from socket. Oh, 778. That was good. Okay, we're around 90 degrees, but I'd say not bad for around 750 watts, don't you think? 95 is the throttling limit, by the way. So it's pushing 770 watts. Look at that. The M1 Ultra is like 4.5 times slower, something like that. But then when trying to test some of the things, I discovered that there is some kind of an issue here. And I'm trying to figure out, where does the issue actually come from? Is it the cabling? Is it the GPUs? Is it something else? Is it some settings that I don't know of? Basically what's happening is sometimes we're getting an error when we're trying to use all of the GPU power. And especially when adding a secondary GPU, I'm trying to figure out if this is the riser cable, because we don't have enough space to add 4. Oops, did I give you the spoiler alert? GPUs in top of each other. We have to kind of spread them out and use riser cable, which basically is an extension of the pod. We're gonna slot it into the PCA slot, and we're just gonna move the slot somewhere other part of the PC case. And we're doing that. There has been some kind of an error. Sometimes you don't get picture out. Sometimes we have an error. We don't get the full power draw. Sometimes we're not measuring this. What is the cause? To be honest, I don't really know. But we did fix that. I did feel slightly cheeky and thought that maybe we could add even a 5th GPU in there. But then I realized that the clearance is just not going to be enough, and it's just not going to work out. But it would have been nice to have the ProArt RTX 4080 Super on the top there. Ooh, but no, it's not going to work out. Now, it took me a long time to figure out what on earth is going on with this rocket chip. Sometimes some of the GPUs are coming up. Sometimes I do have video output. Sometimes I don't. Sometimes I do get a blue screen of death. Sometimes it just switches off. Sometimes it just, there's nothing there. But eventually I figured out what was the problem. I even ordered multiple PCI riser cables, because that is one of the key elements here. Sometimes the PCI riser cable on Amazon is advertised as PCI 5.0 compatible, but actually that could be a lie. And in my case, it was a lie. So once I figured that one out, that made it a lot simpler. I paid a lot more to get normal PCIe riser cables. Finally, when I figured out that the riser cable was an issue, there was another issue. That for some reason, for this particular motherboard, if you've got something in the secondary slot and then the first slot, it's just not gonna work. it just doesn't want to show you both of the GPUs. If you have only one of those occupied and then another one on the third slot, there's no problems. Even if it's anything else, I just couldn't get the GPU to show up. As long as there's not something in the first and second slot, it's no problem. But that was the final key to get every single GPU show up. And finally, when going to V-Ray, to show some of these 3D rendering guys, because remember, there's actual people who need that type of PC power in the world right now. So let's see how it works. 3 RTX 5090s and one 4090 going at full belt in V-Ray, utilizing all of the GPUs. How much power are we going to be pulling? I've got all the GPUs loaded into there. This is a big moment of truth. We're idling at 415 watts, something like that. I'm going to press go. Heck knows what's going to happen. Are you ready? $500, $600, $700. We're doing it. 1700. 1600 watts. Okay, 2 kilowatts, 2.2 kilowatts. Two point 2.3 kilowatts. Oh my goodness. But it's working, boys and girls. We are rendering. Over 2.3 kilowatts. Come on, give us a score. It's got to be more than 12,000. This is really good news, and this is absolutely purely bonkers. Now remember the SSDs that we installed earlier on in the video? Well, there's a problem. I don't actually have enough ports on the motherboard to connect them all. There's over 26 of them. How do I get them all connected? Well, that's why you need this special card. And I didn't want to pay the full price, so I ordered one from, Asia. Basically, this is not some B-Tech version of the card. It's very high-end. It's just a little bit of an older version. This is a card where I can get SAS to SATA ports. In very simple terms, what that means is basically from our PCIe slot, I can make the PCIe slot into lots of SATA ports, and this card actually, because I bought it used, also came with the cables. Usually you have to buy the cables separately, and they can be quite expensive as well, but it came with the cables. So basically now I had to do was all the SSDs that I had put in the system, I had to take everything kind of off again, plug the power into those cables, because what I didn't know is there was no reason to plug in the power previously, because these cables have a special connector. So one goes into the SSD or hard drive, and then the data and the power gets connected to that cable. So because I had the cable already connected to the SSDs, we had to redo all of our work. But eventually everything was connected and we could see all of the different SSDs in there. And we had to decide, what on earth are we going to do with all of the SSD storage? Are we going to just have so many different SSDs in there? But then my question was, we don't even have enough letters to assign to the different hard drives. We're gonna have to figure something out. So there's something called storage pooling in Windows. Basically what this means is you're gonna take all of the different SSDs and you're gonna just put them all into one pool. So in essence, you just see one thing on the side and all of these all ranked together. And the thing is, you can actually expand it later on when you add something else in. You just add it to that pool and the storage gets bigger, bigger, and bigger. So that's exactly what we did. Now, surely this PC can do more than just 3D render. Well, it can do a lot of 3D rendering and a lot of CPU computing power. But when I was asking Alex for advice to kind of really figure out how good this PC and what else can it do, he recommended running LM Studio and some of the large language models. And surprisingly, or not so surprisingly, it's pretty good at doing that. Now, what you've already seen is how all of the GPUs can utilize in 3D rendering. You've also seen how much power draw this PC can draw. But finally, there is the aspect of 1 terabyte of RAM and 96 core CPU. Why do you need it to be that powerful? Here's a few use cases why you might need 1 terabyte of RAM in your system. Number one, 3D modeling. Perhaps if you're a Pixar or animation studio, you're rendering really large scenes, then having more RAM, you just need that because they can't all fit on VRAM on your GPU. You're going to have to use the CPU to render. So to have a high core count CPU and lots of RAM will help you speed up that massively. Number 2, large scale data processing. So if you are either finances in banks or in genetics and you're trying to calculate very, very large data sets where you have lots of data, having it all on RAM will make the calculation a lot faster because the CPU doesn't need to go and find the processing data on SSD, but it's much closer and it's all stored in RAM. And thirdly, if you're doing large fluid or physics calculations, for example, in F1, if you're trying to make the car more aerodynamic and you're trying to figure out how's the air and everything going to work, or you're doing some kind of fluid chemical calculations in oil or other rigs, then you need a lot of RAM because neither can the GPU help you. You have to do it on the CPU, depending on use case. And having large amount of RAM is very, very useful. And fourthly, as an extra, you can actually take this PC, this CPU, and then kind of slice it into lots of other multiple CPUs. A server basically is that. You can make 8 12-core CPUs out of this machine and make all the different machines accessible over internet and then share this out to all of your other people in your workplace, for example. So the people in your workplace don't necessarily have the computing power on their machine. They might have a tiny, tiny one to just run kind of a screen and keyboard and mouse and the program that connects actually to this server. And then all the computing gets done in there. But let's do a little test. How much RAM can we actually utilize doing normal things that you and me might do on a PC? So as you can see, I've got lots of things open. In fact, lots of different Chrome tabs. I've got Premiere Pro open, Media Encoder open, everything that I can think of is I have open there. So let's just start the Photoshop benchmark there as well. I have got lots of different tabs open in here and lots of Tech Notice videos. I'm just going to go through the tabs so it would start playing all of them and actually load them. So there we go. I think we got to the end now, roughly. Yep. So absolutely tons of them open right now. Let me have a look. How much RAM are we using? 86 gigabytes right now. PutureBench is open. On Media Encoder, we're going to press render. It does the audio first. So we're about 91 gigabytes right now, 93 gigabytes. There we go. Let's just double check if we can have, yep, everything is open everywhere. Everything is open. So RTX 5090. So let it render that, might as well. Let's have a look. Okay, 127 gigabytes, 129, 135. I think our media encoder. Yep, there we go. That's rendering now. 134 gigabytes. We're gonna go to Premiere Pro and let's just kind of scroll through the timeline. A project open here, lots of different things happening as well. So I'm gonna press play. Okay, there we go. It is finally starting to struggle. But this is not RAM struggle, this is CPU struggle. 128, we've come down a little bit. There's Tech Notice. Let's open some more videos. And these are all open, as you can see. I've watched them all. Let's get them all going here. I'm gonna close that. I'm gonna open that project again. While we're doing that, I'm going to open LM Studio because another amazing thing that this PC can do is run your large language models locally. Now, one of the downsides of this is that because I've got multiple GPUs, I can't unload everything onto all of the different VRAMs because we're still limited to a single GPU VRAM like the RTX 5090 with 32 gigabytes. At the same time, we have something like this here, Gemma 3, which is about 15 gigabytes in model. So we're going to load all of that onto our VRAM and then ask a question. Okay, let it do its thing. Now, this model is actually bigger. So this is Llama 3.3, 70 billion parameters. And I'm going to load this, but this is bigger than our VRAM, which means that it's going to load some of them onto our RAM. And as you can saw there, it's peaked to 150 something megabytes in RAM. So it's going to start to use some of our RAM because that's what we were trying to do here. As you can see, we're 154, 57 gigabytes there. Now what we're going to do with this one is render in to out. And when we render the sequence, it should use CPU and we should see the RAM usage. There we go. We've reached 200 gigabytes. 203 in fact. This probably doesn't help because we're just slowing our GPU down, but we're not necessarily making it any faster, or it's not using any more RAM. Okay, as you can see, we're rendering on Premiere Pro. Media encoder is going. RAM is going a little bit up. Let's try this. As you can see, no matter how hard we try to push it, we can't really get past 200 gigabytes or something like that. If you know how we should do that, let me know in the comment section below, and perhaps what PC should we build next. I'll see you soon. Bye-bye.